Here we go, last section of chapter 6. Today's lesson is over the trapezoid and the kite. So a trapezoid is a quadrilateral with exactly, and it's important that you know that it's exactly one pair of parallel sides. So a trapezoid will only have one pair of parallel sides. A trapezoid is not a parallelogram, and a parallelogram is not a trapezoid. It's not where we have this overlap like we did with like the rectangle and the square and the parallelograms. Trapezoid, only one pair of those sides is parallel. The other sides cannot be. So I drew a couple trapezoids here. These ones are not probably the ones that you're used to seeing, but I wanted to kind of show them that way and show them in like a different orientation. Some different vocab words you need to know with these is there are two bases in a trapezoid, and the two bases are the sides that are parallel to each other. So they don't have to necessarily be like the bottom side. The bases are parallel. And then the other two sides that are not the bases are called the legs. And this one here is a leg also. And if you just want to write the legs are not the bases, that might be helpful to you. And then what we have is we have base angles, and there's actually two different pairs of base angles, just kind of depending on how you're talking about them. Really, probably what you want is to look at the isosceles trapezoid when referring to base angles and some of the properties of that. So an isosceles trapezoid, I guess I didn't include a picture here for you, so we'll just draw it in. An isosceles trapezoid, this is the one that you're probably used to seeing the most, where you have like those two sides that are parallel, but then these legs are congruent. So for an isosceles trapezoid, you can maybe just write two congruent legs, or the legs are congruent, and then those other sides obviously can't be the same length, but they are parallel. So just keep in mind, all of these properties are properties of an isosceles trapezoid. The first one is that each pair of base angles are congruent. And in this case, this here would be one pair of base angles because they're the angles that are adjacent to that base. And then this pair here would also be congruent. And again, that is only if this is an isosceles trapezoid. This doesn't take into effect if it's not. One thing quick that is true for every trapezoid, and maybe you just want to make this note off to the side, the angles here are consecutive interior angles. And if you just remember from before, those are going to be supplementary, but only the ones where you have like the two parallel lines. So if it's an isosceles trapezoid, they really just have to give you one angle, and then you can figure out all the rest. For example, if I say that this angle is 65 degrees, this one here is also 65 degrees, and I can come up with those other two by just taking 180 minus 65, and both of those would be 115. For this next one, the property is that you will have congruent diagonals. So if you draw those diagonals in, if this is an isosceles trapezoid, the diagonals will be congruent. And we should probably put some letters on here. so we can talk about those sides. I would say here that TA, so segment TA is congruent to segment PR. And that is the second property of an isosceles trapezoid. The next one really just kind of mirrors this first one, but I wanted to put this here too. You're going to be able to tell that it's an isosceles trapezoid if you have one pair of congruent base angles and then you will know that the trapezoid is isosceles. So you already have to know that it's a trapezoid, you have to know that those sides are parallel, but if you have this pair of angles here being congruent, that would be enough to let you know that this is an isosceles trapezoid. Okay, and then for this example at the bottom it says, to save space at a square table, cafeteria trays often incorporate trapezoids into their designs. So if W, X, Y, Z is an isosceles trapezoid, so I'll just go ahead and mark that, and angle Y, Z, W, so this whole angle here is 45, and it says that WV is 15 centimeters and VY is 10 centimeters. We want to go through and answer the rest of these questions. So with this, we know we want to find X, W, Z. So this whole angle here will also equal 45 because those base angles are congruent. I want to then find WXY, so this angle. Remember that those angles are going to be supplementary to each other, so I can just take 180 minus 45 and I get 135 degrees. For the next one, they want us to find the length of segment XZ, so that whole thing will be 25 centimeters because it will be the same as this diagonal when you add those up. And then the last piece I want to find is XV, so that's this part. Well, that part's going to be the same as that one, so the answer to that would just be 10 centimeters. Down here for the mid-segment of a trapezoid is the segment that connects the midpoints of each of the legs. So the mid-segment is going to be exactly halfway between the bases. And because of that, there's a couple of special things that happen. Because of that, the mid-segment is actually the average length of the bases. So what I could do is I could call this one like base 1 and this one base 2, and I could add those up and divide by 2, and that would equal the length of the mid-segment. Another thing that will be true is this will always be parallel to the bases. You'll see us use this first one the most, where you know that it's the average, and you could use that to either find one of the missing bases if they tell you this length, or they might give you both of the bases and you're finding the mid-segment. Either way, you can just use this formula over here. And then the last special type of quadrilateral that we're looking at is the kite. And this kind of looks like maybe a kite that you could fly, but what you need to know for this class is that a kite is a quadrilateral with exactly, again, it's really important that this is exactly 2 pairs of consecutive congruent sides.
I'll show you something funny.
Okay, well, can you show me in just a minute? And with that then, just like everything else, there's a couple special properties. If this is a kite, those diagonals are going to be perpendicular. So diagonals are perpendicular. And then you have right triangles, so I'll just make a note off to the side. When you have right triangles, there's a really good chance that you might be using the Pythagorean theorem to find some different side lengths for those. Another thing that happens is when you have a kite, you have exactly 1 pair of congruent opposite angles. So 1 pair opposite angles are congruent. The other 2 angles will not be congruent, and I know it's written pretty small, but it says here that if this angle is 90 degrees and if this angle is 60 degrees, well, you can use that to find these other angles because these angles are going to be congruent to each other. And you'll remember that in any quadrilateral, all 4 angles are going to add up to equal to 360 degrees. So what I could do is I could add those 2 up and take that away from 360. So 360 minus 150 is 210, and then I could just divide that by 2. So each of these angles would be 105 degrees. And that's kind of how you're going to be using questions like that for the different angles. So for this example here, let's say that this segment is 6. Let's say that this whole length here is 16. And this portion here is 24. So with that, we actually have 2 different congruent triangles here. This point is the midpoint of like this crossbar. So that would make each of these pieces 8. What I can do then is I can find any of these other lengths, and let's just say I want to find, let's do the whole perimeter. Let's find the perimeter of this kite. So what I would want to do first is I'd want to find, like, let's say this side. So we have this right triangle. I can use the Pythagorean theorem to find that side. I'd set this up 6 squared plus 8 squared equals, let's call that x squared. So we have 36 plus 64 equals x squared. So that is 100. And x would be the square root of 100, or that would be 10. Well, because these sides are going to be congruent, because it's a kite, I don't necessarily have to redo the Pythagorean theorem for this side. I would just know that that side is 10 also. If you really wanted to, you could, but you'd just be doing 6 squared plus 8 squared again, and I wouldn't bother, typing that into my calculator again. And then for these sides, these are both going to be the same because it's a kite, and those sides are going to be congruent also. So I would use the Pythagorean theorem with the 8 and the 24 now. So 8 squared plus 24 squared, let's just call this one y, just for a different variable. So we have 64 plus 586 equals y squared. So when you add those 2 up, you should get 640, and you take the square root of that. You have some options here if you would like to change this. I would probably just change that to a decimal. Let me have to go to a calculator quick. I don't remember what that's going to be off the top of my head. So 640 when you take the square root of that, it's about 25.3 after you round it. So 25.3, and each of those would be 25.3. And then what you could do is just add all of those sides up. So let's see, 25 is 50, 60, 70, so it'd be 70.6, and that's an approximation because we did have to round for that square root, but that would be the total perimeter of that kite. So I look forward to helping you guys with this in class, and I hope you have an awesome day.
How about you just come up, guys?
Can you just show me from up here?
I can't. You just have to come up here. It's really funny.
It's really
you have
funny?
to see.
Okay.
Come outside, and I'll post stuff outside.
What? It's just a pile of leaves.